Good morning, all of you. Myself, Jyoti Pathak, Assistant Professor in Chemistry, Government LBS College, Kotputli. In my last video, I just discussed about the preparatory methods of alkenes, and today in this video, I'm going to discuss about the chemical reactions of alkenes. So, first of all, we will talk about combustion reactions. Combustion actually means burning in presence of oxygen. When alkenes burn in presence of oxygen, produce CO2 and water. And a large amount of energy is produced in this reaction, which is known as heat of combustion. So how can we write this reaction in form of chemical equation? 2CnH2n plus 2 plus 3n plus 1 O2 gives 2n CO2 and 2n plus 1 water. So when 2n moles of alkenes reacts with 3n plus 1 moles of oxygen, 2n moles of CO2 and 2n plus 1 moles of water are produced. For example, if methane, 1 mole of methane reacts with 2 moles of oxygen, 1 mole of CO2 and 2 moles of water are produced. Similarly, N-pentene, when reacts with 8 moles of oxygen, 5 moles of CO2 and 6 moles of water are produced, and minus 845 kilocalorie per mole, it indicates delta H. It means in this reaction 845 kilocalorie per mole is liberated or produced. So this combustion reaction is very important from the point of view of domestic uses in cooking food. Methane and a mixture of lower alkenes show combustion reaction, and the energy produced is used while cooking food. The second one is pyrolysis or cracking. Pyrolysis actually means decomposition or rupturing in presence of rupturing on heating at high temperature. So alkenes on heating at temperature 400 to 600 degrees Celsius, they form lower hydrocarbons. This process takes place in absence of oxygen. So we are taking the examples of propane here. Propane CH3, CH2, CH3. On heating, we are just looking here a mixture of propene, ethene, methane and hydrogen is produced. If we use catalyst chromium, vanadium or molybdenum oxide, CH bond depletion is preferred, or if we use silica, alumina or zinc oxide, CC bond depletion is preferred. The third reaction is isomerization. Alkenes consisting of a straight chain structure, if heated on high pressure, 35 atmospheric pressure and 200 degrees Celsius temperature, in presence of AlCl3HCl or AlBr3HBr. We have to make a correction here. This is actually AlBr3HBr. This is AlBr3HBr mixture. So, alkenes consisting of a straight chain, if heated on high pressure and 200 degrees Celsius temperature, in presence of AlCl3HCl and AlBr3HBr, isomerize and produce branched alkenes. Normal butane, N-butane, has been converted into isobutane or 2-methylpropane in these given conditions, and N-hexene also isomerize here and give a mixture of 2-methylpentane and 3-methylpentane. Next reaction is oxidation reaction. Combustion is actually complete oxidation, while in oxidation a mixture of CO2 and water is not produced. Instead, we get alcohol, aldehydes and acids. So oxidation takes place in presence of metallic catalyst, and alkenes are burnt on high temperature and high pressure. Methane is oxidized when it is burnt at temperature 400 degrees Celsius and 200 atmospheric pressure in the presence of copper metal catalyst. Methanol is produced, and methanol on further oxidation converts into formaldehyde, which on further oxidation gives formic acid HCOOH. This reaction is used in soap and vegetable oil industry. Alkenes with tertiary hydrogen oxidize by KMnO4 and K2Cr2O7, and tertiary alcohols are formed. Here we are just looking that CH3 whole thrice CH is converting into CH3 whole thrice COH. A tertiary alkene has been converted into tertiary alcohol. Next reaction is aromatization reaction. Alkenes consisting of 6 or more carbon atoms, if heated in presence of Cr2O3 or Al2O3, convert into aromatic compounds. So, N-heptene has been converted into toluene here. This is actually CH3 or methyl group, not a carbon. So N-heptene has been converted into toluene in presence of Cr2O3, Al2O3, and at temperature 600 degrees Celsius and 15 atmospheric pressure. The next reaction is insertion of CH2 group. Propene, when reacts with dimethyl CH2N2 diazomethane CH2N2, it gives butene and 2-methylpropene or isobutene. So this CH2 group, this CH2N2 or diazomethane actually produces CH2 which is known as carbene, and actually the reaction of propene and carbene takes place here. So thus the insertion of CH2 in propene produces butane and isobutane. Next is sulfonation reaction. On reaction with fuming sulfuric acid on high temperature, alkene forms alkane sulfonic acid. Fuming sulfuric acid is actually a mixture of H2S2, H2SO4 and SO3. So C6S13H when reacts with H2SO4 and a mixture of H2SO4 and SO3 at temperature 400 degrees Celsius, C6S13SO3H, or we can say hexane sulfonic acid has been produced here. Similarly, RCH3, if we are using RCH3 as a reactant, RCH2SO3H is produced here. So alkenes when react with fuming sulfuric acid, alkene sulfonic acid has been produced. The next reaction is chlorosulfonation. In presence of sunlight and pyridine catalyst, alkenes react with chlorosulfonic acid and form alkene sulfonyl chloride. RH when reacts with OHSO2Cl in presence of light and pyridine, RSO2Cl and water are produced. The reaction takes place by free radical mechanism. Cl2 in presence of sunlight produces Cl free radical, which reacts with ethane producing ethyl free radical and HCl. This ethyl free radical reacts with SO2 or sulfur dioxide producing C2H5SO2, which further reacts with chlorine producing C2H5SO2Cl, alkene sulfonyl chloride. This alkene sulfonyl chloride reacts with water, and this Cl is substituted by hydroxyl group, C2H5SO2, OH is produced, which On reaction with any OH, sodium salts of this alkane sulfonyl sodium salt has been produced here, or sodium alkane sulfonate has been produced, which is used as detergents. The next reaction is, and the last reaction here, is nitration. On heating with nitric acid, alkenes form nitroalkenes. We are taking the example of ethane. Ethane, when reacts with nitric acid HNO3, nitroethane has been produced here, and water is also a byproduct. If we take propane, this is actually C3 alkane or propane. Propane, when reacts with nitric acid at 450 degrees Celsius temperature, a mixture of all possible lower nitroalkenes is produced. So nitropropene to 1 nitropropene, 2 nitropropene, nitroethane and nitromethane. A mixture of all these products have been obtained. So how this reaction takes place? Actually, it takes place by the method of free radical mechanism. OHNO2 or nitric acid, it depletes and converts into free radicals OH and NO2. OH free radical reacts with alkene, producing alkyl free radical, which on further reaction with OHNO2 or nitric acid produce ROH and nitro NO2 free radicals. This free radical, alkyl free radical, when reacts with nitric acid, RNO2 is formed, nitroalkanes is formed. So we have just seen some reactions like nitration, chlorosulfonation, sulfonation, insertion of CH2, aromatization, oxidation, isomerization, pyrolysis or cracking, and combustion reaction. Thank you.